we're going to work with an algorithm in this book, Algorithmic Thinking, by Daniel Zingaro, who I don't know, I've never met, but I'm going to show how we can solve one of the problems in the Algorithmic Thinking book using the Epic Loot paper computer. Now, for this test, we're only going to need our index cards. We're going to need some variable cards and also the bonus variable cards from Card Basic Deck 2. All right, so I just started reading this book. It's really good. And we're going to work with the problem food lines, which is really the intro problem. It's, I guess, the simplest problem. So let's start there. It's on page XXVI, which I think is 26. All right, so the problem says there are n lines of people waiting for food. And the number of people waiting in each line is known. Then there are m new people will arrive, and they will join the shortest line. The line with the fewest number of people. Our task is to determine the number of people in each line that m people joins. And then he goes through and kind of talks about how to solve this, think about it. And he has an example. Suppose there are 3 lines with 3 people in line 1, 2 people in line 2, and 5 people in line 3. Then 4 people arrive. And then he walks you through solving the problem. So let's just kind of stop right there and put it aside and set up our computer. Now there's actually code here to solve the problem. It's written in C. C is its own ball of wax. So I'm just going to set up the paper computer. Make sure this is visible. And we're dealing with some pretty small numbers. So I shouldn't have to go too far. So here we go. We've got, we're sort of in 8-byte mode, 0 through 7, and we have -1 there in case we need it. Could probably go a little further, but can't quite see that. So we'll just move this down a bit, give it a little more space. All right, so what we have to do is figure out, okay, what are the variables? All right, that's a really important question. So he talks about n and m, and then he also talks about the lines. Now, we're going to look at m and n. So we're going to use number. Where is it? Num. Which I cannot find. It must be still in my box somewhere. Hold on. We'll use this one. All right. So we have num, and we use that for n. And then we'll use, let's use temp for m. So remember that n is the number of lines. So the sample input he gives us is 3 for, put it on top, I think it's good, for n, and then m is the number of people who want to join each line. And that's a pretty important number. Instead of using temp, let's find a better number for that. Maybe I want to use target. I feel like I'm missing all my variable cards. Here we go. So we'll put that here. All right, and then the reason I wanted to use the X, Y, and Z is I want to track the number of people in each of the 3 lines. So we know there are 3 lines, and so I've got 3 variable cards, and I want to track the number of people in each of these lines. So the first line, which we'll call X, has 3 people. Second line, which we'll call Y, has 2 people. And the third line has Z. Now our mission is to make sure that each person is added, right? There are 4 people, and we're going to go counting backwards, right? And then we hit 0, there are no more people to add. And as we add each person, we find the shortest line, we increment it. Okay, so that's sort of the algorithm. And at this point, I'm not going to write anything down. I'm not going to do anything other than kind of work it out in my mind. That's where the cards can help us. And then later, as I play with it, I can work on the algorithm. So the output he's looking for is 2, 3, 3, 4 for this particular input. To really do a true test, you would test it with a variety of inputs. So let's just make the sample input 3, 4, 3, 2, 5 yield the result of 2, 3, 3, 4. And this is kind of a real world problem. You know, you go to the food store and you always want to find the shortest line, which I've always found turns into the longest line. Like the shortest line doesn't necessarily take the shortest amount of time, because some people have big orders, some people have small orders, some people just take more time, they talk more than others. All right, so we've now actually visualized this problem. So we're going to start with the first user, user number 1. And what we're going to find is that it's very easy to tell the shortest line. The shortest line is always X, Y, or Z that is closest to the left side, right? Remember that Y is less than X, which is less than Z. So it's very easy to visualize. And when we're going to write this down later, that'll make it easy. So the first person comes along, joins line Y. We add 1 to that because now there's an additional person, and there's one less person to join the line. So that's our first loop. Now, interestingly enough, we come to a problem. It's easy to solve, though. Now we have 3 people, so the next person comes along, and what are they going to choose, X or Y? At this point, it doesn't really matter, but I'm always going to choose I don't know, the lowest alphabetically, right? So X comes before Z. If I have to make a choice, I'll choose X because it comes before Y. So I'm going to increment that by 1, and I'm going to lower our target by 1. All right, now we've got another loop. That's 2 loops, pretty easy. So now what I want to do is the next person comes along. We're going to say, okay, what's the line with the lowest? Line with the lowest is 3. And by the way, I forgot to check my output as I went along. But we started with 2, right? Then we went to 3. Then now we're at 3 again. And we're going to move this to the left, decrement it, and we increment Y. All right? And now we come to the final person, wants to join the food line. This is so easy, another turn of the loop. And so I'm going to choose X again because it becomes alphabetically before Y, but it doesn't really matter. So we're choosing 4 and move X over to 5 because we're adding 1 to it and decrement it. And we're done. And if I recorded my output, we would see that we have 2, 3, 3, 4. We've got the correct output. So that was pretty easy, right? And, you know, he has code here written in C. And, you know, there's a lot of C work you have to do. You have to indicate the type. You have to create an array. You have to create some functions. And, you know, we'll do all that in Card Basic in the next step when we record this algorithm. But, you know, we basically solved it. And we did that through visualization and by you know, using variables to think about the problem and break it down into pieces. All right, I hope that's helpful. So why don't you test that out, do that yourself. You can get this book, Algorithmic Thinking. I don't have a relationship with the publisher, but I think it's actually a really good book. It's a little advanced, to be honest with you, but it's something that is sort of timeless. Like a lot of computer science books go out of date. This one will probably never go out of date because, you know, what you're going to learn, these advanced algorithms never go out of date. They're eternal.